Good, Kostas. Good to have you.
Nice to meet you.
Yeah.
Nice to see you in Athens.
Yes. No. Okay, Kostas, you've done some rather fascinating research based around homeostasis or functional homeostasis in animals, as you call it. Could you give us a basic idea of what the term expresses in this context and what the research was about?
Okay. First, I would like to thank you for the welcome, for your good words about our research. And then to get to your question, this functional homeostasis, it combines the homeostasis with the resilience as an idea, in the sense that homeostasis is the ability that each organism has to resist to stressors, to changes, basically. And the resilience is the ability to adapt and regain again the physiological status. So if you combine both of them together, we can talk about functional homeostasis as a relatively new term to describe both of them together. Now, if we want us to reflect more on this term, it actually looks into the way that the cells and the tissues and the animals react to their environment. So basically, the biomarkers that we are trying to understand, discover, and reflect on have to do with all this cellular environment and the deviations that we can expect to a physiological, to a healthy condition, and the deviations, the size, the range of deviation that we can expect in a challenge condition or a disease condition if it is something worse.
Mm-hmm. So why is the functional homeostasis such a key pillar for sustainable and also especially resilient animal production?
Mm-hmm. The understanding that we start to build on this homeostasis front is that I sometimes call it as a thermostat. In our houses, we have, let's say, a way to manipulate the temperature. So we can be within a physiological range that we feel comfortable, but someone might be comfortable at 20 degrees, another might be comfortable at 22 degrees. This will have an impact on the energy and nutrients, in the case of animals, that are required to be physiological and be ready for production or actually produce. So in an extent, if we can understand how homeostasis works and we can manipulate in a positive manner some of its elements, we might be able to compensate for energy and nutrients, which takes us to sustainability in the way that we utilize our feed resources in a more wise manner and with a direct impact also to the environment that can get us to what some people call precision nutrition at some stage.
Okay. Now, in your research, you formulated basically a concept of a sweet spot, of a golden ratio in the context of this functional homeostasis. Could you explain that for me?
Yes, the golden ratio, actually, as we are in Athens and we are looking at the Parthenon, it reflects back to the ancestors that introduced the term. The golden ratio, or the sweet spot, if you would like it in a different, more easier term, it is the space where we can combine different elements and optimize them all together. So the way that we perceive the contemporary animal production and nutrition is to combine health aspects, performance aspects, environmental aspects, welfare aspects, product quality aspects, all together. We just do not look only on performance efficiency. We are looking also at health optimization, at resilience, at product quality, which is still largely overlooked. And my understanding is that it will gain its true value in the years to come. We will be looking more and more into quality. So all of it together, all this golden ratio, allows us to become more efficient, totally efficient. And I think this is the way that we can drive this planet to the true sustainability. This is the, let's say, the broader picture that I could describe this.
Yeah. Makes sense. I'd like to talk a little bit more about the actual stress recovery process that or basically from homeostasis over stress to recovery back to the homeostasis to say. How does nutrigenomics come in here? How does it allow us to measure these eternal responses in practice?
The nutrigenomics is the basic level. Basically, it relies on the transcriptomics, the way that the cell is perceiving, creates a response to a change and produces a transcript, which we can collect and measure, and then make assumptions for what is going to come next, because the next levels are the proteomic levels and the metabolomic levels. Likely for those researchers like ourselves that are involved into actual animal trials, so that we don't have only the idea of what the biomarker level is, but we also have the idea of the whole trial, of how the animals performed, if there was disease, if there was something, a challenge. Then with the first level of this information, the nutrigenomic level, we can combine it with the performance level and have a better idea. And it's also this way efficient, because it's, let's say, you know, that research takes a lot of R&D input and significant amounts of budget to carry. This level of research is also economical, if you allow me to say, in terms of discovery. It's a very fast, efficient process that you need also to combine with the upper levels. The top level, to my point of view, is the actual animal level. So if you have an idea of how things have evolved in the phenotype of the process, then you can learn. If you don't have this idea, you cannot learn from the biomarkers at the transcriptomic level on its own.
Okay, so we need actual expression on the phenotype level.
Exactly, we need to see the phenotype. Did the animals grow? How much did they grow? Did they have disease? What was the disease? And did they have to eat more to make the same weight? All this information is necessary to start getting back to the transcripts and then learning, so that then we can extrapolate the transcripts to the performance and use modeling to do the actual process.
Yeah, makes sense. Now, in this slide, you conducted a rather complex experiment via response surface modeling, and it was about finding optimal combinations of optimal combinations of metabolizable energy, so basically the energy that is available for the metabolism to metabolize, crude protein, and probiotic inclusion, which I think was basically the interesting part here. Talk to us about this.
This was a very interesting trial that we conducted with our partner company some years ago, in the sense that we have an interesting probiotic formulation, and we wanted to learn more of how this combination would act in different diets. In this respect, we formulated diets differing in metabolizable energy and crude protein. Actually, a detail is that we kept the ratio of metabolizable energy to crude protein the same. So basically, we took the specifications of the hybrid, the particular broilers that we were using, taking the recommendation of the hybrid manufacturer at 100%, and then we reduced down to 10%, 5 and 10%, and we combined these reductions with probiotic application. The point was to see how the probiotic will affect the performance and the biomarkers that we were interested, and if there could be some sparing of energy and nutrients enabled via the probiotic inclusion. The idea was not to make a matrix value for the probiotic like it happens in enzymes. The idea was to see whether the actual probiotic creates somehow a better gut environment and a better gut health that allows the animal to economize nutrients and energy and make production. So this assumption and initial question was studied in detail with the response surface methodology. We managed to create empirical mathematical models for various responses where we learned the impact of each factor, energy, protein, and probiotic inclusion on the actual performance parameters. So it was a very good exercise and a very good learning trial that, first of all, gives us the tools to suggest inclusion levels which are functional and work, and understand more about this homeostasis using different combinations of dietary factors. So all this trial was a very good start for what followed onwards in recommending inclusion levels, in doing further trials with challenge factors, and learn even more and gain also confidence. For me, it's very important that when we are doing research to also gain the confidence in the mode by studying the actual mode of action of any feed additive or any nutrient or even stress factor. We need to understand this so that we can actually devise efficient diets in the future.
So what were the effects on notable gut biomarkers then of this that you observed?
The effects is that at that time we studied mostly inflammation and apoptosis and another biomarker that I can recall now. Let's keep an antioxidant capacity, the way that the animal has the ability to detoxify and the ability to resist to inflammation, or the way that the apoptotic clock, the natural programmed death, can shift to faster or slower speeds. So the idea was that probiotics, the outcome was that probiotics at the majority of the energy crude protein combinations studied could actually generate a fingerprint of these gut biomarkers that were in what we perceived as the more healthier condition. Not that the rest, this was not challenge diet, was not into the physiological range, but there we managed to discover a range, let's say from the 2 to 20, and within this range we could see the variations of all these responses. So we are into the physiological, but as we said earlier, we are discovering where the cells actually need to expend less energy and nutrients to stay healthy.
Yeah.
And this is combined always with better performance.
So I think this is already quite clear, but still I'd like you to outline in what way then does this impact feed formulation?
It depends. For example, if based on our study, we can spare some energy and crude protein from the actual formulation by introducing probiotics, this of course will lower the cost of nutrition, of the overall nutrition. And the other thing that we have discovered is that even if we introduce, without changing the diet, if we add on the probiotics at a certain inclusion level, the nutritional efficiency, the cost of nutrition per unit of production, improves versus the control. So actually the cost of addition, it is offset completely by the efficiency that you gain, which is it is very important. But why is it happening is the next question. Because the improvement in the gut environment and all the digestive process allows the animal to use more of its nutrients and energy for productive purposes rather than maintenance purposes, the homeostasis part. So this is the thermostat is lowered to a, let's say, to a lower temperature, still okay, but just this thing makes, this tiny change makes a huge difference to the productivity of the animals and the health of the animals.
Basically what a lean body does versus what a body does that is not lean. Like a pulse that runs lower in a runner versus somebody that doesn't run.
Exactly.
Yeah, yeah.
So we need to learn how we can modulate this.
Yeah.
And this, of course, depends on many factors, not only the diet. Is the genome, the environment, the challenge stressors, the sex, if it's male or female. So all of this is very complex, but I think that there is light at the end of the tunnel. Basically, we can see that yes, progress is being constantly made by many researchers in this world, that bit by bit we understand more, and this is the important thing.
In the same context, you conducted another experiment that basically focused on heat stress with the inclusion or the exclusion of probiotics. Tell us about the setup and your findings there.
This setup was the latest setup that we have run with the probiotic. It's actually utilized two groups, only a control, no probiotic, and the recommended inclusion level by the manufacturing company of the probiotic. We had high replication, 18 replicates per group, because we wanted to make sure that if there were any differences, even low, could be detected by the statistical power that this very powerful design with replication would generate. The heat challenge was part of the experiment, but it was very essential because what we learned, we knew from previous experiment, but this was confirmed in a much deeper notion, was that the challenge creates unfavorable conditions for animal productivity, the heat challenge in particular, to all the animals, comparing to the non-challenged. But the way that some bioactives like probiotics function allow the animals, the functional homeostasis comes into play, and this resilience, it works much stronger. Therefore, the animals resist the heat challenge in a much better way, and they actually regain their performance much faster than the control animals. It could be interesting also in this particular trial, the setup, we didn't have differences in mortality at the finisher phase. However, our research in other cases have shown that if the heat challenge is even stronger, mortality occurs even from the first day that the challenge takes place, and it can be very severe. So it is very, very important, if we understand all this and that we can protect our animals. The climate change is a fact. For those who don't believe it, I'm afraid that they are losing some critical information, but it is a fact. In Greece, we're becoming warmer and warmer year by year. Therefore, if we have the means, when we expect at least that the challenge will take place due to weather conditions, to fortify our diets with all these bioactives to protect our animals, firstly from dying, mortality, and then to assist them in recovering much faster their production rate.
Okay, excellent. Yeah, this is extremely relevant considering the situation we have in our summers at this moment.
Yeah.
For the producer on the farm level themselves, all the science is extremely interesting, but at the end of the day, in day-to-day production, it becomes relevant to be able to monitor these biomarkers on a farm level without having to send blood or whatever to a lab and wait for results, especially let's say we're in a heat wave. I've included probiotics. I need to see what's going on. How far are we from that?
This is a super topic that you mentioned. Online farm monitoring is becoming more mainstream. There is already significant biomarker development in this respect that does not require tissue, blood, or any other tissue sampling. So basically, I think that the principle here is to actually build serious models from specific studies that we can actually predict performance outcomes based on a few biomarkers, because most of the work has to be done research-wise, then built with the artificial intelligence, with the AI, for example, assist us more in building more robust models that we can actually predict performance with as little biomarkers as possible. Now, the extent to which specific sampling, like you mentioned, I mean, for me, taking a blood sampling and actually devising a system that with a blood stain you can actually take a lot of biomarkers reading on the spot, having a specific equipment, is something which is, it will help us be more, let's say, it will be easier to predict. There has to be some sampling to validate and actually gain more confidence. The other stuff that we could say is that through the developments that serious companies that invest in R&D are doing, actually by understanding the mode of actions of their products, is somehow, this is like a guarantee for me that when you use this specific formulation with the recommendations that the company is giving you, that it will actually function and protect you from significant damage or something which will be unfavorable to your production purposes. So we don't have to reinvent the wheel every time we go into a farm. I think that a lot of the effort that is being made is actually to validate our lab and small-scale results to the farm, get the confidence that we need, and then we can just apply. Not always have to measure and measure and measure. So any strategy, any product, and anything that can be formulated, it will have the backup of all this knowledge. So it will work at the end of the day. And this is something which I'm really, let's say, serious into doing. We just don't need good results when we do research. We like also the bad ones, because the bad ones will teach us and will make us question again and again and do the right steps to understand what's going on. So the mode of action, it is, a lot of people talk about the mode of action. I'm glad to see more and more serious mode of action, serious studies regarding mode of action taking place. If we go 10 years ago, this mode of action in many things was not there. Now, people are investing more and more into understanding how it works in a multi-factor, multi-variable environment. So we just have to have confidence, be open-minded, hear the specialists and the scientists, and work together. Otherwise, no matter what solution you produce, even the way that someone will execute it on field might not bring the desired result. It needs collaborative attitude and let's say a wider perception of all the things involved, but not at the farmer level. For the whole, let's say, stakeholder
environment. Yeah. So there's a lot of people and variables at this point coming into science, and there's already a large body of data we already have to build on and include. So how does AI and predictive modeling help you with this ever-growing task?
It is a very powerful and serious tool that, however, needs lab data to grow on. So no matter what AI might generate on its own, if it doesn't really have the basis lab work that is required, no serious prediction can, let's say, evolve. So it is a very good tool, but it has to be built and grow on reliable data sets.
Of course, yeah. So this work, to a certain extent, feels like breakthrough work. You know, we have some, especially for feed formulators and also animal producers, we have some very interesting insights here that could potentially really change how do we approach the precision approach over the next 10 years. What do you see happening over the next 10 years that will move the needle based on these findings?
I think that the next 10 years ahead of us, basically, is they will be very challenging. And they will be very challenging because if the world continues to act in a logical manner, we will grow population-wise higher, and then what we consider as a given, which is a food production, is not given at all. So my concern is that we need to pay, first of all, a higher respect to the first line people, which are farmers and those who are in the primary sector, as we say, agriculture and farming, because they produce the food that we consume. And this is not something which is given just like that. So we start by respecting the people on the field, and then scientifically we need to try build more our knowledge on how things work in the best possible manner. We will have to compete for food resources and feed resources. We need to make animal agriculture less competitive to human nutrition. So basically we need to act by using biotechnology and utilizing all the feed resources in a circular manner. We hear a lot about circular economy. We need to build on that, not like term-wise. We need to actually act seriously and utilize anything that can be diverted from becoming waste to something which is useful. Use it to animal and human nutrition, because for me, what is fit for animals is also fit for human nutrition. And act in an environmental conscious manner, try and minimize greenhouse gases and any other emissions, optimize nutrition, go to this precision, so basically minimize excretion. Or even if we have excretion, to utilize it in another efficient process. So make it green and circular and precise. The precision will actually drive these two elements. And so the future is challenging, but it's also very promising. And I need to take the opportunity to all the young people, to our students, to people who are thinking of getting into agriculture, that there is a bright future. We need to act. We need also our politicians, of course, to act on this front, so that we can encourage people get involved in the primary sector. Otherwise, I hope that biotechnology will manage to create the food of the future without farmers, which is impossible. Okay, and in this sense, the future, I think, is bright despite the challenges. It will make us. The challenge will make us better. At the end of the day, it should make us better if we want to continue to exist. So this is my point of view. Work harder and smarter.
Great. I love it. We need the farmers and we need them to do well. Let's help them. Kostas, thank you so much.
Thank you. Nice.
It was very, very interesting, and I wish you all the best with your further work.
Thank you very much.